All right. Any questions you have before we start?
No, sir, as of today.
Okay. So in the previous class, we learned that SD-WAN is not something new. It is
Correct.
a combination of various things that was there uh, in bits and pieces put together to achieve something in a very big level. This is worldwide. SD-WAN can be worldwide. But if you take ECI, maybe between two data centers, multi-sites, not that big like SD-WAN, but
Mm-hmm.
concept is same. As I said earlier,
Yes.
the the orchestrator, the controllers are same. There we call it as epic.
Epic.
Here we
Correct.
call with three different names.
Correct.
That epic functionality is broken down into three separate modules, and we call it as vManage, vSmart, and
Smart and
vBond.
lead one. Correct.
There in ECI, the spines are acting as a backbone. The spines are acting as a route reflector.
Correct.
The spines are acting as a switch fabric. If you compare to Nexus 7000, the spines are acting as switch fabric. Here, we also have switch fabric, but we call it as WAN, the internet, the public network, the transport. Simple word, transport. So there's not much difference. Even if you see the GUI, for those who have done UCS, Cisco UCS manager, it's similar. And for those who've done ACI, it's same like that, ACI and UCS. Not much means, those who are aware of this UCS manager can manage SD-WAN. Those who are aware of ACI can manage SD-WAN. The GUI don't have that much complexity. It's not that difficult. But the vManager graphical user interface GUI, if you want to understand completely, then you should have known a lot of concepts like MPLS thoroughly, BGP thoroughly. For example, you can enable X Connect. You can go to a feature and you can say, I want this interface to be a layer 2 VPWS. You have an option. So if you don't know what is X Connect, then you will not be able to use that feature. You will see a radio button. You will see on or off the radio button saying X Connect. So this is an example I'm telling you. So if we don't know what is .1x, then you will not be able to use those features. So SD-WAN is not teaching any protocol or any concept. It's a tool. vManage is a tool via which you can apply those known concepts easily without typing any commands on any device. You can also configure through GUI, through CLI, but it will be a little difficult for us to, a lot of typing works. Using GUI is more easier than using CLI. So in short, what I want to say here is, to manage a big network, the software defined is very friendly. But if someone knows only this SD-WAN, but not strong on routing protocols, switching protocols, don't know much about QoS, security, then they will not be able to understand anything inside the GUI. This is just for an information to understand what SD-WAN is. Just to understand what SD-WAN is. SD-WAN is not going to easy someone's work when they don't know BGP. No. You should have good understanding of BGP, BGP attribute, the path selection, iteration in BGP. Only then he will be able to use it in SD-WAN tool. In that way, it makes his job easier, meaning he can simply go click some buttons and push the configuration to the edges, sitting on single place with single monitor. He'll be able to push configuration to various sites. The V edges and C edges, imports them and establishes the tunnel as per the policy. So any question now?
No, nothing. So I'm able to grab.
Okay. So what do we see here in this picture here is before SD-WAN. Before SD-WAN, we used to tie the applications to a link. Even we had a lot of overlays before SD-WAN. Traffic engineering with MPLS is an overlay. GRE is an overlay. IPsec is an overlay. Frame relay is an overlay. EPLS is an overlay. VXLAN is an overlay. EVPN, VXLAN. In all this, what we used to do is we used to tie the application to the link. What does that mean? For example, here if you see path 1, voice application, I need 10 millisecond latency and a full mesh topology. Path 2, backup traffic, I just need a hub and spoke topology. So voice requirement is fulfilled only when it is mapped to link path 1. So we tie it to that. The rest of the traffic we tie it to path 2. This we used to achieve using BGP or QoS, policy-based routing, and so on.
Typically, in a production, it will be over the single link only, right? So using QoS, you would have given a priority. If this traffic comes, maybe Some priority weight you give that, and then you
Yeah,
serve it. Yeah.
it was like that. And the traffic was going either via MPLS or via internet. It depends on to which link we tie. Maybe via lease line connection or maybe uh, layer 2 VPLS or VPWS, the last switch, the leased line, the internet or MPLS. So any one of this will be in use for different application, different path we might have binded. Whereas SD-WAN uses the internet or the MPLS connection or the lease line connection as a switch fabric. So this is one type of connection. This is another type of connection that you have in the internet. For SD-WAN, that is going to be simply a switch fabric. And all the edge devices or IO modules. The control plane on this is determined by this control plane module, which we called as SD-WAN control plane, meaning we got 3 controllers. So this control plane module is the brain of this big topology, SD-WAN topology, SD-WAN network. And these controllers are mostly softwares which sits on VMs. They're not hardware. They sit on VMs. They're softwares. The only hardware in SD-WAN that we have is the VHS, IO modules. Even that one we have software, 1000V, C 1000V. So SD-WAN is like using internet as a switch fabric and having VHS as a data plane and having some pieces of software as a control plane. The control plane decides the path selection here in the IO module, determines the data plane. And data plane plays as per what the control plane has dictated. To communicate, it is the same WAN connection that will be used. So we need to make sure all these controllers are reachable from remote sites. All the edge device should ping the public IP address of the controller, the control plane controllers. So this picture explains us that.
So when you told about the controllers being reachable from the edge devices, right? So internally, they would have assigned a private IP. So it means natting would happen, and then it's like that, right? So it's not
Yeah,
just
correct. That will be taken care by vBond if
okay.
natting is done. Prefer not to. It's okay even if you do natting, but if you keep it as direct public IP address, it will be easier.
But public IP address in the sense, since we have three different controllers, so it will be difficult for us to arrange three different public IPs, right?
Yeah, but this is SD-WAN. It's okay. You have to manage 3 different public IP addresses
Okay.
because it's serving a lot of things. We no need to. It is reducing lot of cost. SD-WAN is going to reduce a lot of cost. Initially, yeah, it is going to be a heavy cost. You need to buy the controllers, edges, but later on, it is going to be less cost compared to the traditional network. So just buying 3 addresses is not that big. That also you don't need big bandwidth.
Even this
Well,
can be hosted in some cloud as well, right? Some
yeah,
AWS or something. So they give the public IP, so
yeah.
it'll be, yeah.
Another thing is, if you are trying to use one address for 3 controllers using netting, that don't work. Even if you have private address, you will need 3 public address for netting because you cannot do netting from outside to inside if you have dynamic net or PAT. You need static net, one-to-one net. Only then, from outside to inside, the request can go. You understand what I'm saying?
Yeah, correct.
So, uh,
So this port forwarding, whatever, that does not
no,
work,
no,
right?
no. That's not going to work for. That is unidirectional actually.
Mm-hmm.
Only the static net is bidirectional.
Mm-hmm.
Site point to point is means one-to-one netting. That is bidirectional. Static net is one-to-one. So you need one public IP address for each private.
Mm-hmm.
So if you want to leave it in public, good. Or if you feel like no, I want to hide it. I don't want to reveal the original IP address. I want to hide it with private IP address and do netting. It's okay. You can do it. OMP will take care of it. Sorry, this vBond will take care of it.
Having said that, since it has public IP address, so it is vulnerable in terms of security, right? So someone can do a DDoS attack or whatever. So it would be exposed to the public, right?
Yeah, then why we have Palo Alto, ASA,
Okay.
what they are doing?
Yeah, yeah. So they take care of these things. So it means these things will not reside in the edge. So it means there should be some infrastructure or a firewall residing in front of it, and then behind it they need to.
Yeah,
Mm-hmm.
correct. So if you want to do netting, you do it on firewall,
Mm-hmm.
or leave it as a layer 2 firewall. Have public IP address on the controller. Have one layer 2 firewall,
Okay.
transparent firewall. So no need of netting if you do transparent firewall. All right. So here, what we see here is whether it is physical or a virtual underlay network, SD-WAN doesn't care about it. Why? Applications are binded to the path, not to the link. In SD-WAN, we have a virtual overlay. For each application, you will have a specific topology. For each application, you will have a virtual overlay. The physical or the virtual underlay is totally abstract. Applications are binded to the virtual overlay. Transport, this is the word I was trying to recall. Agnostic. Transport agnostic. Transport, we don't care whether we are pushing through an MPLS or or switching or an IP routing or any other type of connection. It's transport agnostic, SD-WAN. It purely depends on the virtual, means overlay path, overlay provided path. So you can have your own turns. You can have your own service policy. That is what here it means. You can go and get scanned against the firewall. Then you may go and get into a load balancer. You have your own policy in moving the packet, pushing the packet towards the destination. In central policy, like you got to vManage, in which you're going to define the policies. So the policies are not going to be written on every single router as you used to do for QoS. On every hop, you used to say trust COS, trust DSCP, and then match DSCP, and then go to the policy and say use this interface, or you set some burst value. You don't do those things for every hop here. I just took QoS as an example because you were talking about QoS. So we used to do various things on every hop, but now a centralized policy, and you got network topology as per your wish, because it's an overlay and the controller can decide whether you need a hub and spoke or full mesh overlay or hub and spoke overlay. So this is the key, transport agnostic. Because of this, you can have this, you can have this. And another good thing is you got a centralized controller. Yeah, this is it. SD-WAN is all about paths. What sort of path I want, not the links. Whether it is an MPLS link or internet link, agnostic to this. The control plane in SD-WAN can be in various places, can be in one single site, or it may be distributed across multiple sites. This control plane in SD-WAN or simply like BGP route reflector, where their job is simply to reflect the route. They are not going to be the tunnel endpoints. If you take BGP route reflector, BGP, you will be having overlay MPLS layer 3 VPN. I'm not talking about SD-WAN, I'm talking about layer 3 MPLS VPN. There will be two PEs between which the tunnel is established. But the routes are given through a middle guy who is a route reflector. Route reflector's job will simply reflect the route from one PE to other PE. Sometimes this route reflector router will not be a router in the path between these two PEs. The job of this route reflector is to provide route information, period. It won't be a part of data plane. Likewise, the control plane in SD-WAN is also like a route reflector. It provides the data plane information to all the edge devices.
Yeah.
So again, let me repeat quickly. Route reflector is going to be, it's going to provide the route information in BGP. It need not to be there in the data path. Same way, SD-WAN control planes need not to be there in the data path. It can be anywhere. As I was telling you, another example, the tower, the flight controller is controlling the takeoff and landing of every flight to the airport from the airport, but he is not in any of this aeroplane. He is simply a control plane, and the pilots are the data plane. The data plane decides whether to land or take off based on what the tower guy sitting in the tower tells. Next thing is SD-WAN. Per application, you can have a topology. Application can choose the network topology. Yeah. So, sorry. You can have your own topology. We are not now dependent on topology because we don't care about the underlying. Yeah. So the applications are going to be over the path, not over the link. So the path decides the topology, the the policy that we write, the TLOCs decides the path. We'll talk about the TLOCs later. So what I'm simply trying to say is we are no more dependent on the physical topology. You will have your own virtual topology, as it is said here. You can have your own path like this. Go one first stop in the firewall, go again to this one concentrator like this, and then go somewhere else. It means you can decide. Right, this is the real.
I think you're muted.
Now this shows you the complete picture of this components of SD-WAN, building blocks of SD-WAN. We got three controllers: vBond, vManage, and vSmart. vBond is an orchestrator. Why we call it as an orchestrator? Only based on this, only based on what vBond decides, based on the vBond's decision. The vManage and vSmart will know how many edges we have. Our edges will know their owners. Edges will know their vManage, vSmart only through this vBond. So basically, he's the orchestrator. He's the one who is the gatekeeper, the gate man. If no gate man, no relationship between inside and outside. Edges cannot be a part of SD-WAN if this gate man, if the gate man didn't agree. So vBond is an orchestration. vBond needs to raise his hands up and down for the music to come. Only then the music is played in the trumpet. That's why he is an orchestrator, vBond. Without vBond, no SD-WAN. vBond is the gateman. vBond is the one who authenticates the edges based on the whitelist model. We'll talk these things in detail later. But you have already heard about this in your internal. Someone was sharing with you a day before
Correct,
yesterday.
correct, correct. Yeah.
So
Yeah, but these things for high availability, they will have multiple and HA, right? So they would have multiple instances. As
mm,
you also mentioned, it can be spun across the sites as well, correct?
yeah.
See, I was just wondering, see, when you think about VPC, this keep alive or for the configuration sync, we used to have a link between these two devices, these two switches, and then configuration would get exchanged, or when it comes to even UCS FI, right? So you have the configuration which is synced. So is there something which is also there as part of these controllers where the configuration will get synced with each other?
See, this orchestrator is connected directly to whom? vManage. So vManage knows everything. It is based on the vManage command. vBond works. vBond don't do anything of its own. It depends on vManage. So vManage is the head to which all the vBonds are reporting.
Okay.
vManage knows who is connected where, and vManage knows who has enrolled through which vBond. vManage is all-knowing person. He's like a boss to which every vBond reports. So there is no need for. So if you ask me what is the link between these vBonds, we manage only the link. It's vManage that acts as a VPC peer link. You took VPC as an example for this side. So it acts as a VPC peer link. Any other question?
No, no. No.
So we don't have you don't have any separate wire to sync between vBonds. That's what I mean. That's the answer you are expecting, right?
Yeah, yeah, but okay, so that's fine about vBond. So how about other controllers, whether it can be vSmart or vManage?
Again, the same story.
Okay,
vSmart is also connected to vManage, all the vSmarts. There may be more than one vSmarts. Yeah.
there may be more than one vSmart.
Yeah, yeah.
So whatever this vSmart has that information, so the same thing would be replicated, or it maintains a separate.
Same thing will be there.
Okay, now let's assume that we lost one of the vManage or vSmart at this point of time. Maybe since you told it can be a VM, right? So if it is lost and again it comes back, right? At that point of time, see other vSmart would have served or vManage would have done this thing. So how will the other vSmart or vBond which vManage which came up again, which is back online now, how will it get to know that information?
Hmm. For now, you leave that redundant vManage. Let's speak only about vSmart.
Okay, okay,
vSmart is available in various places, and if one of the vSmart goes down, when it comes online, to whom it will notify first? To the vManage. vManage has got the latest update to push to vSmart.
okay,
So there won't be any problem.
okay. So it means there will be a constant interaction between these controllers. Apart from
Yeah,
vBond, which is initially, this
correct.
vManage and vSmart will have constant interaction between
These
these. Okay.
three are always in contact. They always speak. These three will always in group. Wherever they may
Okay.
be, they will always be talking each other.
Okay. So they have some keep alive and things like that, which keeps.
Yeah, I have a picture here. Maybe it is different presentation. Um, I'll show you some other class. What I was trying to show you is this all will be in same LAN if it is in one site. These
Okay.
three will be in same LAN if it is in one site, so that they
Mm-hmm.
can have fast communication
Okay.
instead of routing. And if you are keeping in cloud, this all will be in same LAN. Same LAN. That is the best option. Keeping in cloud, you don't need to have much redundant. No need to have duplicate of these smarts.